In this screencast, we will introduce you to the kinds of tubing that are used in extracorporeal circuits. Here you can see the 5 most common sizes of tubing that are used in extracorporeal circuits. Next to the sizes, we have also placed the volume of tubing per foot. So the 1/8 inch tubing holds 2.5 mLs per foot of tubing. The 3/16 inch tubing holds 5 mLs per foot. The 1/4 inch tubing holds 9.6 mils per foot. 3/8 inch tubing holds 21.7 mils per foot. And the 1/2 inch tubing holds 38.6 mils of fluid per foot of tubing. It is important to note that these sizes refer to the inner diameter of the tubing, not the outer diameter. The inner diameter of the tubing is measured across the internal lumen of the tubing, whereas the outer diameter is measured from the outside edges of the tubing. Therefore, tubing with the same inner diameter may have very different outer diameters if the wall thickness is different. By adding the additional variable of wall thickness to your nomenclature, you can easily identify the kinds of tubing that you want. You will find in your clinical practice that 1/8, 3/16, and 1/4 inch tubing is commonly found in both 1/16 and 3/32 wall thickness, whereas the 3/8 and 1/2 inch tubing is generally only found in 3/32 wall thickness. So while both of these pieces of tubing have the same inner diameter of 1/4 inch, they have different outer diameters because they have different wall thicknesses. Different wall thicknesses give the tubing different characteristics. A thicker wall makes the tubing a little more rigid and reduces accidental kinking of the tubing, and it also reduces the risk of a raceway rupture. However, it's worth noting that the wall thickness of the tubing will influence how you properly set the occlusion on your roller head pumps. To really understand that, we have to look at how a roller head pump uses tubing to generate flow. Roller pumps generate flow by compressing PVC tubing between steel rollers and a rounded metal raceway. As the roller head rotates, the roller pinches the tubing at the strike point and continues to move the point of compression around to the other side of the raceway. As roller number 1 is rolling off of the raceway tubing, the second roller is rolling on, and thus continuous forward flow can be generated. In certain clinical applications, it is common for perfusionists to place more than one piece of tubing through the same roller head pump. These tubings may have the same or different internal diameters, but they must have the same wall thickness. To wrap up this introduction, I should leave you with a few terms. The most common composition of the tubing that we use is PVC, or polyvinyl chloride. Silicone tubing has also been used, but PVC is by far the most common tubing to date. Memory is the characteristic of the tubing to return to its original shape after it has been compressed. Durometer refers to the hardness of the material. It is a feature of the chemical composition of the PVC. Spallation is a process in which the PVC fractures and fragments. It results from the repeated compressions of the tubing between the rollers and the raceway. Spallation is responsible for microemboli generation, and if it continues through the entire wall thickness of the tubing, will produce a raceway rupture